Okay guys, welcome to your video tutorial on abstraction and refinement. Today we're going to learn actually how to break down a system. So here's our syllabus dot point. The top-down approach to solution development first happens by looking at a problem. So last lesson you learned about understanding the problem, so problem definition, compatibility issues, performance issues, boundaries of the problem, functionality requirements. Once we have a really good picture of that, then we can start looking at, okay, this is actually what the client wants. Let me see if I can then break this system down into smaller bits. So we have to look at, well, what are the bits of a system? So systems are complicated as hell. Software development is a precise and detailed process. If I just sit there with the client and the client says, I want a point of sale system, that's a huge problem. And it's really important, even if I'm only developing by myself or I'm developing in a big team, that I break down the problem or the system that I'm trying to solve into smaller parts. That way, if I break it down into smaller parts, I'm able to see different parts of the system and tackle the problem in a far more logical way. So refinement, also known as the top-down design, is about progressively breaking a big problem into a series of smaller ones. So refinement is essentially what we're doing. And once I break that system down into smaller parts, I can focus on the smaller bits in isolation. And this means I'm actually able to abstract the system. So I might be able to work on a small part and not necessarily have to care about the big picture if I've done the appropriate planning and I've done the appropriate refinement or top-down design. So let's look at how I do break down a system, and let's look at what top-down design is. So if I look at a system, this is a system hierarchy flowchart. Can I make it really clear? This is an example. What you're meant to get from this flowchart is that there's 1, 2, 3, 4 layers. Not every system hierarchy will look identical to this. This is an example. My system is made up of one or many programs. In this example, there's 2, but depending on how big my system, if it's only small, there might only be 1 program. If, for example, my system is huge, there might be 4 or 5 programs. But the system is first broken down into programs. Those programs are then broken down into one or many modules. Those modules are then broken down into one or many subroutines, potentially. You might notice here, this system has 2 programs. This program over here has 2 modules. This module here has 2 subroutines, but this one doesn't. This other program over here has 1 module here and 1 module here, again 2. This module has 1 subroutine, this has 2. Now, you'll very unlikely ever get a system that has 1 system, 1 program, 1 module, and 1 subroutine. That doesn't really make sense. More than likely, you'll get 1 system. If it's smaller, you might only get 1 subroutine. You might only get 1 program. Then you'll likely have 1 or more modules. Under those modules, you'll more than likely have 1 or many subroutines. So, yeah, it's a little bit confusing. I know this is an example of what a system could look like. It's not necessarily the only example. What you need to take from it is that the hierarchy goes system, program, 1 or many, module, 1 or many, subroutine, 1 or many. So what's actually involved in each section of this hierarchy? Well, a system is comprised of all the programs in the suite. The system's the overall thing I'm looking at. Then the program is comprised of all the modules that are required to perform the task. The modules group together subroutines or perform linking between tasks in subroutines. And a subroutine is a set of statements that perform a logical task. So let's look back and then let's look at what those definitions are and how they fit in. These subroutines are designed to perform a particular task. If I was looking at a calculator system, I would have 1 subroutine for adding. I wouldn't mix adding, multiplying, dividing, all of my other functions in 1 subroutine. I'd have separate. But what happens if something I'm doing in this subroutine has to talk to this subroutine? I can't actually cross over. You'll notice that there's no linking lines between those two. What actually happens is I have to go up here and I can connect them through a module. Okay, by the same regard, modules can't talk to each other. If I need to connect something from this module to this module, in the coming lessons we'll look at variables and the kind of ways I might want to connect them. This module can't talk to this module, so I have to go through a program. Okay, again, this program can't talk to this program, so I have to go through the system. But if you think about it, subroutines perform the logical tasks. I should only limit one logical task per subroutine. I can connect subroutines through modules. The modules allow for connections between here and do things that perform tasks that will have to happen between both subroutines. That modules are connected through the programs are connected through the system. Once again, I'm going to reiterate that this is an example of what a system hierarchy could look like. There isn't necessarily always two programs, two modules under each program, and then, two or one subroutines. This is just the hierarchy and an example of what it could look like. And that's it, guys. That's system hierarchy.